I'm Anil Kumar. Welcome to my series on providing you with solutions on international test papers. Here we have picked up Advanced Mathematics. This is a test paper of 2018 and we'll now solve question number 8. So this question is based on quadratic equations. Let us see how to solve such a question. Figure 1 is a graph showing a trajectory of a rugby ball. The height of the ball above the ground, h meters, has been plotted against the horizontal distance x in meters, right? So both these are in meters. Measured from the point where the ball was kicked, so that is the point. The ball travels in a vertical plane. The ball reaches a maximum height of 12 meters and hits the ground at a point 40 meters from where it was kicked. So the maximum reached is 12 meters. So right in the center, it is going to reach the maximum, which is 12 meters. So let's say this is 12 meters and that is the 40 meters mark, right? A, find a quadratic equation linking h with x that models the situation. So we are going to assume here that's a parabolic path, right? And then we'll model. So our assumption is parabolic path. Now, we could use the different forms of the equation. So capital H can be written as, if I use the intercept form, we have got 1 0 at 0, the other one is 40. So we can say a times x is this variable, x times x minus 40, correct? To find the value of a, we can substitute this. Highest point will be at the midpoint at 20, correct? So if I substitute 20, then the height should be 12. So from there we get a, I'm substituting 20 for x, so I got 20 minus 40, and that gives us 12 divided by, this is 20 times 20, but with a negative, 400, correct, is the value of a, right? So that becomes the value of a, which you could definitely simplify and write this as negative, dividing both by 4, will gives us 3 over 100, correct. So our equation can now be written as h equals to minus 3 over 100 x times x minus 40. Clear? So that is how we can relate height with the distance x. Now, the ball passes over a horizontal bar of a set rugby post that is perpendicular to the path of the ball. The bar is 3 meters above the ground. Part B is, use your equation to find greatest horizontal distance of the bar from O, and part C is, give one limitation of the model. Okay, so let's begin with the limitation itself. So limitation could be what? Limitation is no air resistance. Right, so that is one thing. No wind, right? So it follows a uniform motion as shown without any resistance. Now let's look into find the greatest horizontal distance for the bar. Now bar is 3 meters above the ground. So basically what we are saying here is that somewhere here it cleared the bar and this distance is, well, I should have taken here. Let's take it here, right? This is 12, 6, much less light, right? So let's say this distance here is 3 meters. We need to find the value of x when the height is 3 meters, correct? So we can substitute height as 3 here, and then we get minus 3 over 100, and we need to find the value of x, correct? That's the whole idea. Okay, so let's write this as, let's multiply them, x squared minus 40x. So to solve this, we can take it to the right side, and then we have a quadratic equation to work with. So 3 and 3 cancel, so we get minus 100, or you can say just 100, okay. I'm taking 100 to the other side. Okay, let's write it plus, doesn't matter. So we just multiplied, cancel these 3, equal to, I kept minus here, so minus 3x squared plus 120x. Is that clear to you? So multiplying with negative gave us 3 and 3 cancelled, sorry. So let's do it like this. When you multiply here, multiply with cancel 3's, okay, so we get 1 here. So we get this as 100 equals to, open this bracket, with minus x squared plus 40x, clear? Now that becomes a quadratic equation. So we can bring all these together. So we get x squared minus 40x plus 100 equals to 0. So now you could actually find the solution using quadratic formula, right? So switches, we get the value of x. Let me do it here. Minus b, which is 40, plus minus square root of b square, which is 1600, minus 4ac, which is 400, okay, divided by 2 times a, right? So that becomes the value of x. So let's calculate this. So let's calculate the square root part, which is square root of 1600 minus 400, which is 20 square root 3, right? In decimals, it is 34.64. So we can add this to 40 because we want the greatest. So plus 40 and then divide by 2. It gives us in decimals a value which is equal to 37.32. So from here we got the height, use the equation to find the greatest horizontal distance of the bar, and it can be rounded to 37.3 meters, correct? So that becomes our answer. So this answer is 37.3 meters, correct? So I hope the steps are absolutely clear, and that is how it should be solved. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that would be great. In case you have any queries, you can always email me on the address given here. Thanks for your time and all the best.